Hey there, class. Mr. Prusky here. Hope you're having a good day so far. This section we're talking about is Unit 2 for Advanced Math Topics. We're talking about systems. Systems are just more than one equation or inequality. This is 2.1. We're kind of going off of what we did in Chapter 1 with equations. This section is solving advanced equations. So our essential question is, how do we solve advanced equations? So we have a warm-up here. It's solve the following equations, which are kind of a review from more basic stuff. So why don't you guys pause the video and give that a try. All right, so let's go through this here, see how you guys did. So x plus 5 equals 9. We need to do the opposite of what's happening to x. So instead of adding 5, we're going to what? Subtract 5. So we get 9 minus 5 and get it to both sides. X equals 4. Number 2, similar thing. We need to make sure we get the 2x by itself. So how do we get rid of that minus 3? We add 3 to both sides. So we get 2x equals 13 plus 3 is 16. And what's the last step to get x by itself? Divide by 2. We get x equals 8. Last one here. In general, it's a good idea to see if you can distribute and combine like terms before we do any solving. Is there anything to distribute here? Yeah, we got the 3. So we're going to do 3 times x, which is 3x. And 3 times 2 is 6. Equals 18. All right, solving from here, subtract 6. 3x equals 12. Divide by 3. X equals 4. So that's kind of a warm-up from stuff from like Chapter 1 or Unit 1. So, yeah, we're going to make it a little more complicated today. But the moral of the story for this lesson, and like with most things in math, is just don't panic. Just apply the same principles and see what happens. Because usually it's the same principles, just like there's a little twist or thing we have to figure out. But that's the fun of it, and that's kind of what critical thinking is kind of just playing around with stuff until it kind of works here, okay? So we have this thing here. It says fill in the blanks. So why don't you guys see if you can fill in these blanks here, like for what we do to solve. Okay, give it a try. So for solving, we are kind of undoing order of operations, which is PEMDAS. The opposite of PEMDAS is going to be SADMEP, the opposite, right? So instead of doing parentheses first, exponents, we're actually going to undo going this way. We're going to get rid of addition, subtraction first. Then what? Multiplication, division. And then we move to exponents and parentheses. And parentheses are actually like grouping symbols in general, okay? Let's put grouping, okay? All right, very cool. Okay, and so these next few examples are similar to what we did in the warm-up, a little bit more complicated, but you're going to get some weird results, okay? So when you're solving equations, you can get a single answer, you can get no solution, or infinite solutions. So this is kind of a review from Algebra 1 or other classes. See if you can solve these and figure out which ones are one solution, infinite solutions, no solution. See how you do. All right, so number 1 here, anything to distribute? Yep. 8 times r is 8r. 8 times negative 6 is negative 48, equals negative 96. And you get 8r by itself, so we're going to add 48 to both sides. 8r equals, what's that, negative 48. Divide by 8. We get r equals, what, negative 6? Nice. That'd be a single answer, which is like x equals, r equals, that kind of thing, okay? All right, number 2. Anything to distribute here? Yeah, we got to do 4 times x is what? 4x. 4 times 2 is 8. Equals 8 plus 4x. So what you notice about like both sides here, they're essentially the same thing, just mixed around here. So what I still like to do is I still like to kind of solve for x, or kind of move all the x's or variables to one side. So let's do that. How do we move 4x from one side to the other? Well, we're going to subtract 4x, but you'll see what happens when we do that. Well, they're both going to cancel on both sides. So we're left with just what? 8 equals 8, right? Well, is that true or false? That's true, right? So if it's true, and it's just like there's no variables anymore, the answer is just going to be infinite solutions. Okay? And that's it. So basically the same line on top of itself, so they cross everywhere, okay? All right, how about number 3? Why don't you guys do the same thing with number 3, see if you can figure it out, then we'll go through it. All right, nothing to distribute, no like terms to combine here. Let's move all the x's to one side, so subtract 6x. We get negative 11 equals what, negative 4? Is that true or false? That's not true, that's false. So what do you think? Is there infinite or no solutions? There are no solutions for this, okay? All right, very cool. Sounds good. Okay, so now, kind of like I was talking about before, we're solving decimal equations, right? So with this, like I said, just don't panic, do the same thing as before, and just do the same thing as we've been doing, but it's going to be just kind of weird numbers here, okay? So I'm going to leave it here. I want you guys to try what you can, and then we're going to go through some, okay? All right, why don't we just start with number 1 here to kind of to ease into this here, okay? So we have 2.1a equal plus 7.7 equals 13.79. If we just had 2a plus 7 equals 14, right? What would you do first? Well, you'd subtract 7 here. So we're going to do the same thing here, even though it's kind of weird numbers. We're going to subtract 7.7 from both sides, right? Because it's like we're trying to get the 2.1a by itself. We don't reinvent the rules of math just because we have weird numbers, right? So we have 2.1a. 13.79 minus 7.7 is going to be 6.09. Okay, now if I had 2a equals 6, what would I do? Well, I'm still going to divide by 2, but I'm going to divide by 2.1 because I want to undo multiplying by 2.1. So a is going to be equal to 6.09 divided by 2.1 is going to be 2.9. Make sure you think about it. Is it an exact answer or an approximate answer? If you have to round it all, it's going to be approximate. Okay, so now we did one more one together. Why don't you guys try some of these other ones here and see how you do? All right, number 2. We have 0.3 minus 7.9a minus 4.87 equals 6.49. Anything to distribute here? No. Any like terms? Yeah, we got some like terms. There's no other a's, but we have these are like terms, right? Because they both have no variable. So we can rearrange this. We have negative 7.9a. Combined like terms, we're going to like just add the numbers, right? Or like subtract them. So 0.3 minus 4.87 is going to be negative 4.57 equals 6.49. All right. Okay, now we need to get the negative 7.9a by itself. How do we do that? We're going to add 4.57. So we get negative 7.9a equals 11.06, it looks like. Divide by negative 7.9. We get a is going to be equal to negative 1.4. All right, again, always feel free to pause the video now that we've gone through a couple and try these as they're kind of making sense. All right, number 3, anything to distribute here? Yep, got 5.2 times 1 is going to be 5.2. 5.2 times 2x is going to be negative 10.4x. It's going to equal 82.16. We need to get the negative 10.4x by itself, so we're going to subtract 5.2 from both sides. So negative 10.4x equals, what's that going to be? 76.96. All right, divide by negative 10.4. Undo multiplying by that. X is going to be equal to negative 7.4. All right, very cool. All right, try the last one if you haven't already. All right, number 4, anything to distribute? No. Any like terms? There are like terms on the right-hand side here, right? These are both k's. So we have 5.1, negative 5.1k minus 4.48 equals, what's that? It's going to be negative 3.7k. All right. Combine like terms. Now we need to get all the variables to one side. Should we move the 5.1k or the 3.7k? I'd probably add 5.1k to both sides because we don't want like 0 on one side. So we got negative 4.48 equals, what's that? 1.4k. Divide by 1.4. So k, it's going to be negative 3.2 is going to be equal to k. All right. You did well with that. Good job. It does feel weird because it's like decimals, but there's this kind of impending doom or panic that we feel when things get weird, but we just gotta kind of stay the course and do our best, okay? All right, so now we're doing the same thing. Now we're doing fraction equations, which are, really tough. And so, yeah, why don't you guys try solving number 1. Kind of the same thing here. It's going to be kind of messy, and I'm going to actually teach you a easier way after this. But I want you guys to try it. Try to solve for this. Try to solve for x. All right, so for this one, we have negative 3 over 2x minus 3/4 equals 1/2. So we want to get the negative 3 over 2x by itself, so we're going to undo subtracting 3/4, which means we're going to add 3/4 to both sides, okay? But now, this gets kind of messy because now we have negative 3 over 2x equals, now we have 1/2 plus 3/4, right? Well, how do we add fractions? We add fractions, we need a common denominator, right? So what's the common denominator between 2 and 4? It's going to be 4. So we need to multiply this side by 2 to make it a common denominator. So now what we have is we have negative 3 over 2x equals, we have 2 over 4 plus 3 over 4. So now we can add those, and we get, what, 5 over 4? Okay. And then how do we undo multiplying by a fraction? We can divide by the fraction, or what we're technically doing is we're multiplying by the reciprocal. So reciprocal is when we flip the fractions. We're actually going to multiply both sides by negative 2 over 3. Okay. These are going to cancel, because it's going to be literally 6 over 6, which equals 1, right? That's why that works. So now we have over here, multiplying straight across, is we have negative 10 over 12, and we can reduce that. So negative 10 over 12 will become divided by 2, right? Which is the GCF. We get negative 5 over 6. So that's kind of messy, isn't it? So, yeah, if you felt like kind of overwhelmed by that, you should, because it's a lot. And so we actually have, what we teach like here is a shortcut to make our lives a little bit easier. It's called fraction busting. So in the blanks here, put fraction busting. And what we need to do that is basically we're going to eliminate all the fractions by multiplying by a single number. And what we're going to do to multiply by is we're going to multiply by the least common denominator. Okay. If we multiply by that, it's going to cancel out all the fractions. Okay. So let's go ahead and do a couple examples here, right? So we have r plus 1/8 plus 2/3 equals negative 5 over 24. So for this, we'd have to get these to be a common denominator, the 1/8 and 2/3, and then, it's just kind of a mess. So what we're going to do is we're going to just find the least common denominator between these and multiply everything by that, and you'll see why that helps us, okay? So what's the least common denominator between 8, 3, and 24? What I like to do is I like to start with the biggest number, which is 24, and kind of count up by 24s and see if they all divide by that. So does 24, the least common denominator is the number that divides by everything, right? It divides by all the numbers that you have in common, right? So does 24 divide by 8? It does. That equals 3. 24 divides by 3, which equals 8, and 24 divides by 24, which equals 1, right? So if that were not it, you'd basically count up. You go 24, then 48. You keep counting up until you get a number that divides by everything, right? And so for this, we're going to do the least common denominator is going to be 24. We're going to multiply everything by 24, okay? So let's do that. We're going to kind of put parentheses here, times 24, this side times 24. All right. So we're going to kind of distribute this to everything. What's 24 times r going to be? It's 24r. What's 24 times 1/8? Well, 24 over 1. If you kind of want to just distribute or kind of cancel stuff as you go, that's fine. But 24 divided by 8 is going to be 3. And then 24 times 2/3, right? Kind of show what's happening here. 24 over 1 times 2 over 3, right? So 24 times 2 is 48. And 48 divided by 3 is 16. That's kind of what we're doing here. So we get plus 16. And then over here, when you multiply and divide by 24, right, these are going to cancel. So we get just negative 5. All right, now see why this is nice is now we have just a nice, I guess, equation with just no fractions, which I think is pretty cool. So why don't you guys try to solve this from here? All right, anything to distribute here? No. Any terms? We do. We got the 3 and 16, so 24r plus what? 19 equals negative 5. Subtract 19. 24r equals negative 24. Divide by 24. R equals what? Negative 1. Nice. All right, why don't you guys go ahead and try number 3. It's still going to be kind of weird if you haven't seen this before, but give it a try. All right, so number 3, we have this whole kind of big mess here. So the numbers I see are 2 and 4 for denominators. So we start at 4. Does 4 divide by 2? It does. Does 4 divide by 4? It does. So we know that 4 is going to be our least common denominator here, right? So we're going to multiply both sides by 4, everything by 4, and that's going to cancel stuff for us. So what's 4 times negative 1/2? What's that going to be? Well, 4 divided by 2 is going to be 2, so we got negative 2x. So again, you're doing 4 over 1 times negative 1 over 2, if you want to do that. 4 times negative 11 over 4, 4s are going to cancel, we get negative 11x. Over here, 4 times 13 over x, 13 over 4 times x. 4s are going to cancel, we just get 13x. And then 4 times 13 over 2, it's going to be negative 26. Let's see, now we have nice numbers with no fractions. All right, anything to distribute? No. Any like terms? Yep, got negative 2x and 11x. It's going to be negative 13x equals 13x minus 26. Now, it's going to be kind of weird here, but I would actually like move this 13x here to the other side. Minus 13x, we get negative 26x equals negative 26. Divided by negative 26. X equals what? 1? Nice. So you can do the same thing with, like, you know, finding common denominators, like, and stuff, but like fraction busting just makes your lives a lot easier. Work smarter, not harder, right? All right, cool. Solving exponential equations. Why don't you guys see if you can pause the video here if you can figure out how to solve this, but we'll go through it in a second. All right, so yeah, so the way we solve exponentials is we're going to get the exponent by itself and then take a square root, okay? All right, sounds good. So we have x squared plus 4 equals 104. We need to get the x squared by itself, so what are we going to do? Subtract 4, so we get x squared equals what, 100? Okay, and now it's by itself, we're going to take a what? Square root. So now what we need to be careful about, though, is it's saying what number squared equals 100, right? Well, there's two numbers that work, right? We have 10 squared equals 100, but also parentheses negative 10 squared equals 100. So that's, we need, when we do this kind of thing where we like square root of x squared, we need a plus or minus. So it's going to be plus or minus 10. That's going to be our answer. All right, very cool. Why don't you guys go ahead and try 2 through 4 if you like. Give them a try. And decimals are okay, by the way. Decimals are fine. All right, number 2 is the 4n squared by itself. It is. Now we need to get rid of that 4. How do we do that? Divide by 4. We get n squared equals what? 84.5. Undo an n squared by doing square root. So we get n. And since we're doing like it's kind of a decimal, it's a irrational number, we're going to do approximately plus or minus 9.19. That's our answer. Okay, make sure in the calculator you do second, then you do x squared to take a square root, okay? All right, number 3. I get 25k squared by itself. How do we do that? Minus 1, so we get 25k squared equals 25. Divide by 25. And we get k squared equals 1. Square root. What number times itself equals 1? Well, k is going to be equal to plus or minus 1. Okay. Number 4. Get the 3r squared by itself, subtract 3. 3r squared equals what, 87? Divide by 3 to get the r squared by itself. So r squared is going to equal 29. Square root both sides. R is going to be approximately, because we had to round, or it's an irrational number, plus or minus 5.39. And there we go. All right, very cool. Moving on to radical equations now, okay? So remember, radicals are the inverse operation to exponents, or basically like they're doing the opposite to undo stuff here, right? So it's similar to the other stuff where we need to make sure we get the radical by itself, and then we're going to square both sides and then solve the rest, okay? Decimals are okay here too. All right, number 1. So we have this negative 9 plus square root of x r plus 2 equals 0. is the square root by itself right now? It is not, so we need to get the -9, get rid of that. We're going to add 9 to both sides. So now we have square root of r plus 2 equals 9, right? Now it's the square root by itself? It is. So now to undo the square root, what we're going to do is we're going to square both sides, okay? That's going to cancel the square root here. Now we have r plus 2 equals what? Is that 81? How do we solve for r now? We're going to subtract 2. So we have r equals 79. Okay. And there are such things as like extraneous solutions, which are kind of like false solutions and stuff, but we're not going to really focus on those too much right now. Just know that they exist, okay? All right, why don't you guys go ahead and try 2, 3, and 4, see how you do. All right, we have number 2 is 40 equals this. We need to get the square root by itself. Is it by itself right now? It's kind of, we need to get rid of this 10 in front. How do we get rid of that multiplying by 10? We're going to divide by 10. So we get 40 over 10 equals 4. 4 equals square root of a. The square root's by itself. Now how do we undo a square root? Square both sides. So we get what? 16 equals a. There's our answer. All right, why don't you guys go ahead and try 3 and 4 if you haven't yet. All right, we got square root of x minus 10 plus 2 equals 7. Is the square root by itself? It's not. We got that plus 2. How do we undo adding 2? Subtract 2. So we got square root of x minus 10 equals what, 5? All right, now how do we undo a square root? Square both sides. So now we have x minus 10 equals what, 25? Last step is to add 10 to both sides. All right, so we add 10 to both sides here, and we get, these cancel, we get x equals 35. All right, last one, make sure you try number 4 if you haven't yet. All right, we need to get the square root by itself. What we need to do first, subtract 3. So we got square root of 3p minus 2 equals what, 2? How do we undo a square root? Square both sides. So now we get 3p minus 2 equals 4. Now we're to a normal solving here. How do we get rid of the, how do we get 3p by itself? Add 2, so we get 3p equals 6. Divide by 3. P equals 2. All right, nice. All right, last thing is solving for variables. This is basically doing what we just did with all these weird kind of stuff, and we're going to be trying to get a variable by itself, kind of like solving for y when we're doing, it's going to be important for solving for y when we're looking for, you know, graphing systems or stuff like that, doing substitution, that kind of stuff. So it's an important skill. We've been building to that this whole lesson. So yeah, so it says get the desired variable by itself. So like for number 1, it says solve for x, means get x by itself. I want you guys to see how you do with these, and we'll go through them, okay? All right, number 1, we're solving for x. We want to get x by itself. So if this was like 10x minus 5 equals 20, what would you do first to get x by itself? Well, you would add 5, right? But we don't really have a 5 here. We have a c, but that's okay. You can still like add variables and just not really like have it resolve. It just kind of like, it's the same like steps. Nice thing about like the way we solve things is like they prove that like it works no matter what you do. It can be a variable, it can be a number, it can be, you know, it can be pi. It's like it doesn't really matter. So we do the same steps even though it feels kind of weird, right? So now we have on the right hand side, it's not going to combine. They're not like terms. We're going to get just t plus c. All right. So now it's like if we had 10x equals 25, right? Well, that's kind of a bad number, but anyways, what would you do next? Well, you divide by 10, right? So same thing here. We have a times x. We want to get x by itself. We're going to divide by what? Divide by a. So we get x equals t plus c over a. And it's okay that it doesn't really like come down to a single number. It's like just a formula, right? And there's our answer. All right, now we kind of got the hang of that one here. Why don't you guys try number 2, 3, and 4 if you would like. We're going to go through them in a second. All right, number 2, we're solving for y. We want to get y by itself. So, so what do you think for this one? We have p times y over r. This one I might do some kind of fraction busting, I guess. I would multiply both sides by r to get rid of that. With these kind of like solving for variables, I like to like get rid of the denominator as soon as possible usually. I think it makes things nicer. So we got p times y equals g times r. All right. It kind of depends, I suppose, but these are kind of like, because there's like not nice numbers that like resolve, it can be kind of interesting or kind of weird, but in this case, I would probably just get rid of the denominator. Now we need to get y by itself. How do we get rid of that times p? Divide by p. So we get y equals g times r over p. Very cool. All right, now 3 and 4, if you want to try those, give those a try, but these are like pretty applicable because it's going to be what we're going to be doing with systems and stuff. So, okay. Try number 3 and 4 if you like. All right, we need to solve for y, so we kind of need to get this by by itself. So how do we do that? I'm going to subtract ax from both sides. So I have by equals c minus ax. And to solve for y, I'm going to divide by b. And now I have y equals c minus ax over b. All right, very cool. And then number 4, if you want to try that last one, give it a try. All right, same thing, still solving for y here. So we're going to get that 3y by itself. We're going to add 6x to both sides. So now we have 3y equals, do the negative 12 and 6x combine or no? They're not like terms, so we're just going to write just 6x minus 12. Divide by 3. And y is going to equal, 6 divided by 3 is going to be 2. We get 2x minus, and a 12 divided by 3 is going to be 4. So we built you up all the way to this point here because that's going to be really useful for this unit is like when we graph things, it's better to be in y equals mx plus b. At least for me, I think that getting b by itself and stuff or y by itself is really nice. So yeah, if you could do those really hard ones, it'd be really in good shape for when we start graphing systems. All right, that's all I have for you today. Thank you for watching. Have a great day, and we'll talk soon.